Hello everyone, my name is Perumal Jagan and we are doing a malware analysis. In our previous parts, I've shown how to set up a malware sandbox. Uh, I'm not, I didn't show it in detail, but I just gave you the reference. And we actually started doing some static analysis. We have used tool like flaws to start assessing the strings of a binary. Now we are doing a challenge called Malevolent Mod Maker. So it's all about a video game mod file, a suspicious executable file that we are up against. Not one executable. In fact, we have a couple of executables, but still we started focusing on that particular mod executable file and we did the flaws analysis. We have found some strings and now it is time to bring our assessment further. So let me start sharing my screen and you could see the screen right now. I am actually running the tool CAPA against uh, the file MC mod maker version 1.4, and it's been running. It's been applying some rules against this binary to find the behavior of this binary. It's trying to deduce the behavior of the binary, and here it is. You could see the whole detail. So let me go and copy the whole string, and I'm going to store this in text file. So let's see this. I'm going to open a new text file, save this as CAPA, come on, caps on, CAPA basic. I'm going to run this CAPA once again with verbosity. So it's going to give us more results because let me explain that. But let's see this before. Here is the outcome, and you could see the file hashes here. Analysis, static, Windows. It's a PE file. PE means portable executable file, and the architecture is AMD x86 architecture, and you could see the file path. And here is the MITRE attack technique. So this CAPA is actually working with the MITRE attack framework reference. MITRE attack framework is actually a website where you can see the, okay, I think the internet is not here, right? MITRE. So this is the website. So here in this website, you could see the, oh, come on, not org. MITRE attack framework. It's been a long time since I have accessed this website, and here it is. So here you can see the tactics, techniques, and procedure used by a threat actor, and you can see the stages of attack: reconnaissance, resource development, initial access, execution, persistence. So inside every tactic, there will be a lot of techniques. And you can see the techniques that are followed by a threat actor. So for example, if I just click a particular technique, I'll be able to see the threat actors who are using them, and you can see their names, the procedure examples. So you can see the list of ABTs. So who will be using this particular technique. So this is the MITRE framework is, and this tool CAPA is actually working closely with it is actually an integral part. The MITRE is actually an integral part here, and you can see the defense evasion. deobfuscate, decode files and information. Okay, shared modules, anti-behavioral analysis, communication cryptography, debugger detection, software breakpoints, HTTP communication reader header, crypto library, decrypting data with AES, encrypting data with these schemes, and hashing is 256, SHA-256. Generate pseudo random sequence RC4, hashed message code, check string, encode data XOR. Non-cryptographic hash, defense evasion, obfuscated files and information. Okay. Check, okay, here are the capabilities. Check for software breakpoints, anti-analysis, anti-debugging, and debugger detection. Parse credit card information. Okay. check HTTP status code. I think HTTP is the C2 channel. Compiled with Go. It's Go binary. Encode data using add, XOR, sub operations. Encode data base 64, EAES. So more encryption and encoding. Hashing functions. Authenticate HMAC. Get kernel 32 base address. Okay. Enumerate PE sections. Resolve function by parsing PE exports. I think I would have ran it with -VV now. Meanwhile, but anyway, let me analyze it again. It's going to give me more details, but this time I'm going to store these details in a file, right? So let me redirect it to a file samples analysis CAPA detailed.txt. So it's going to store whatever the result is. The result is going to store in this txt file. So I'll open a new tab. I don't want to disturb it. And now what I can do? I think I can probably start doing more static analysis. So let me use another tool called PEStudio. Do I have PEStudio here? Let's see. Static tools. PE I have, PEStudio is also I have. And I go here, I run PEStudio. PEStudio is actually an excellent tool for static analysis of a malware. Okay, so I go open the file. Let's see. Yeah, here is the file. It's a GUI utility. So I'm loading the file, the malware, sample, danger, MC modmaker v1.4.exe. I open it. So it's gonna do some intelligence, the threat intel for us. So it's gonna reach VirusTotal. It's gonna reach some malware database to bring some file hashes and compare it with the current hashes we have. So it's going to give us the results here, but let's see that. But before that, so here is the DOS header, DOS stub, the components of portable executable file, and the file header. And you could see the file header here. What are the characteristics? File can be executed. It's an executable file. So here's the timeline. Jan 1, 1970 UTC 000. The timing is 12 o'clock exactly. I don't think this is actually an authentic time. I think they did some time stomping. Time stomping is actually the process of tweaking the time to dodge the security analysis. AMD 64 is the architecture, the supported architecture. Optional header. Okay. It's been a long time since I did this PE analysis, so I might be struggling in between. So bear with me. OS version, it says Windows 7. Directories for iData, PData, relock, and .data. Okay, let's see the import section. And here is the thing. And you could see the library kernel 32.dll and the list of imports. The functionality is imported from this library. Load library. These are all the things we've already witnessed. Exiting the process, creating the thread, closing the handle, virtual lock, writing the file. So looks like it is also tampering with the file. So the ransomware, what they typically do, they try to encrypt a file and just try to change the extension to a different or weird string. So when a user try to access the file, it's already tampered. They're no longer able to access them. I don't know what happened. So it terminated quickly. So I'll reload this. Okay. And here it is. I think this is what I was looking for. It was not properly opening before. And I could see the flags here. So if I go to the import section, in the flags, I could see some uh, imports with red flags, writing the file WER set flags, what it is. So let's Google it. WER set flags. It's an API function. What's the purpose of it? The fault reporting settings. You can specify one or more following values. Kind of a false reporting. Uh, virtual query, virtual alloc to allocate the memory. Switch to thread, suspend thread, set console control handler, set thread context, get thread context, environment settings, get current thread ID, vector exception, add vectored exception handler. Let's see. Add vectored exception handler. So this function belongs to this library. The order in which the handler should be called. Okay. So there are some red flags here. That's what I wanted to mention. And here is another important and interesting part: sections. Dot tx dot text dot r data dot data dot p data dot x data. I think all these things refer has some meanings. I'm not positive like what it is, but you can see every section is not having the same same privilege, and you can see here the dot text section is having executable privilege, dot data is having the write privilege, dot idata is having a write privilege. I think there is a standard thing for this. So one particular section should not be having this kind of privilege, and this section is having only this privilege. So there are some standards for that. But here there is another interesting stuff is, oh, come on. Process termination. Okay, if I click OK, it's gonna close, so I'm not clicking it. Maybe until I read this. There is a portion called entropy. The entropy is actually, if typically it is higher, then I guess there are some abnormality. There are some anomaly in that. I guess there is a limit. I'm not sure it's a 7 or 6. The entropy limit. Entropy limit in malware analysis 0 to 8. Files with entropy score above 7.2 are frequently flagged as potentially malicious. So I don't see any of the files with more than 7, but I could see one section with 6.2. So which is little suspicious. Okay. And I could see some import flagging here. Apart from that, I don't see anything else. So what I do, I simply click OK and close this. I don't know why it is keep closing. It's weird. Static tools, PEstudio. The PEstudio is keep behaving like this. I'm going to switch it to PEbear, which is another similar tool. Okay. Now you could see the same stuff. A library, just one library got loaded. I don't know whether this binary is actually showing the things that I want. Maybe I can use a tool called DiE. Because the DiE is detect it easy, it's gonna predict is there any packer is used. So let me tell you what is the concept of packing. Packing is actually Um, uh, the term packing, what it is generally mean, enclosing something, enclosing an object with something, right? So that is what this packing term in malware analysis also. Okay, the same thing. Okay, I think I'm struggling. I'm just trying to explain this in a better way. Uh, Packing means enclosing a binary, hiding the binary uh, with something. So they actually call it as a packer. In malware analysis, the term is called packer. If a malware is packed, then when you just try to analyze the packed malware with some tools, then you won't be able to you won't be able to read much details. So what you need to do, you need to unpack the malware before you start assessing it. So that is what called packing in malware analysis. There is a tool called DIE, Detect It Easy, to open a file with, you can open the file here simply. Then it's going to give us whether the file is packed or not. So it's going to predict that. The sample danger, I go to this modmaker.exe and here it is. So it is also giving me the details of the language. So it says it's a Go language, Golang binary. The language is Go, and I could see the architecture, the NDNS, and the type of binary. Uh, if I say detect it easy, um, let's see. I guess you need to apply. You might apply some Yara rules as well here. Uh, the Yara rule predicts some encryptions here. And can I see some packing? I don't think this is a packed binary. Otherwise, we would have seen the results here. Options, file. Okay, let's see. Yara, extra database, deep scan, signatures, hexadecimal. This has some online tools. You can see a VirusTotal API key. So you can just uh, uh, integrate this DIE tool with VirusTotal. If I click advanced, if I click demangle, demangling means unobfuscating, deobfuscating the things. But if I click advanced, I could see more details here. The file size is 5.29 MB. The strings, disassembly, hexadecimal. I could see all the details from here. So it's a useful utility. Let's see. Entropy. Let's see them. So this is the highest value, and it says the status is not packed. I guess this one says these sections are not packed. So there are 78% of chances that this file is not packed. So that's what we presume. Memory map. So I'm just trying to learn these things, this tool, and you can see the hexadecimal format, MZ. So this is the magic byte. So the 4D5A is the magic byte. So this is the magic byte for executable file, the PE file generally. So that's what it is. And what is extractor? I don't know. Yes, it's a hexadecimal representation. Disassembly. So here it is. So the disassembled code, the disassembly of the whole binary. Visualization. Excuse me. Sections, yeah. So the section wise data. Okay. Imports, yeah, the import and its address, I guess, the memory address. Um, the base address entry point is given here. The timestamp I could see here. File info. So this is the file. All right. I don't think it is bad, but let's see. Let's do further assessment. Um, okay, I'm not going to use it now. What else I could do? Maybe can I try to answer some of the questions? I don't know. Let's see. I go to the VM, go here. Let's see. Right from the start, based on the incident details, the .txt file contains and the extension applied to the .txt file, what type of malware infection this is. So we have seen a file with some weird extension, right? So that's what they're asking, I guess. Sample, danger, folder, and you could see Go team. The file extension is Go team. Looks like this one is actually uh, a file, the text file, probably important.txt dot go team. Go team means the extension, the malware extension. So as I said, they have encrypted this file followed by this uh, extension change. So they changed it to Go team extension. So let's do some um, open source, some OSINT, open source intelligence. And also I'm planning to find the file hash to do some probably uh, some open source intelligence with help of VirusTotal. Let's see. So here is the SHA-256 hash, copying the value. So I have copied the file hash and okay, the internet is not there. I keep forgetting it. And so here is the file hash. Let me go to VirusTotal. I think that's the promising website. And what this particular website does, so in this website you can search with the URL, file hash, even with the file, whether you can check whether the file is a recognized malware or not. And look at this. Here is the file, mod maker version 1.4.exe. It's a known malware, and they say it's a stealer, or I don't think it's a steal, it's a ransomware. But let's see, let's go and see the community entry. And here I could see the malware family name, Luca Stealer, Frosty Goop, Dosia. Frosty Goop. Let's search with this malware. There is a Unit 42 blog by Palo Alto, Frosty Goop malware analysis. Frosty Goop, a closer look into the malware behavior and network communications. It's an OT malware, they say. Bustler become publicly known as attacker used to disrupt this. Okay. Frosty Goop is compiled using Go programming language. So this is the Go malware, right? Sometimes referred as Golang. Malware uses relatively obscure open source Modbus implementation. So the Frosty Goop might be the name. Let's see. Can I go and answer this? No, this is not Frosty Goop, it says. So here are some static analysis. Bustle bomb. Is it going to be the answer? No. But in virus total, what we have seen, Frosty Goop, Knight, Luca Sealer, Dosia. What is the question? Um, what type of malware infection this is? So they are asking the what type of malware infection? Ransomware. Is this the answer? Yes. So they are asking the type of malware. It is ransomware. And what mechanism does MC modmaker.exe use to send information back to C2 server? You can either prove it via dynamic analysis. I guess HTTP 6 characters. What command does MC modmaker run, suggesting that it means to execute other binaries or scripts? What is the API key value? I think we need to do further analysis on this binary to answer these questions. But for now, this is a ransomware. Okay, it keeps stopping. PE bar. I open it with PE bar. File, load PE, and I go to samples, danger, modmaker.exe, and this is also loading the same stuff, and I could see some lesser details. I don't see any flags, red flags in this analysis. Okay, so what we need to do next? So let's see what are all the other static analysis options that are up against us. I can use a cyberchef if I find any encrypted stuff. CAPA rules. PEstudio I already did. Yara and Floss. So maybe I can go for the advanced static analysis. I don't know how much I'm gonna get through it, but maybe I think I should be able to do some reference here, because I haven't done the Golang analysis before, because it's quite difficult than the C++ binaries, assessing C or C++ binaries. You might need a separate extension for that. But I guess for now, what mechanism does it send back to C2 server? I'm just thinking how I can crack it up. Let's see. Even if I use some advanced tools like Ghidra to disassemble them, I don't know I'll be able to understand anything. Okay, let's go and see this. I did the static analysis with Floss, right? CAPA. Sample analysis, CAPA detailed. So what I could see here, do I see any interesting stuff? Author, Michael Anhoff Mandiant. Anti-behavioral analysis. So behind each of these guesses, there are some reasons. So that's what they gave here. That's why I had to use -VV for the verbosity in CAPA. Scrolling down, check HTTP status code, and look at this. Check HTTP 2 matches. Communication HTTP client. Author, this one. Function. So here is the function address. Maybe when I do the advanced static analysis, I can directly navigate to this address to see the HTTP communication details. I think it could be used for that. Hmm. All right. I think this is the stopping point. We are already reached the 30-minute mark, so I'm stopping my recording here. Hopefully, we'll be able to get some big breakthrough next time uh, when we are doing this analysis further. Okay, so let me stop the recording. Yeah, actually, I forgot to mention one thing. Do this YouTube algorithms, like, comment, subscribe. I am catching you next time with uh, the same malware analysis. We are going to continue further. So we're going to crack this stuff. Okay. I'll see you next time. Thank you so much.